Hi girls, hello. We're just going to have a look at another functional group today. And before we do that, I just want to sort of start from something you know already, which is showing you a dot and cross diagram here. It's not very exciting, but it is just going to help us introduce something which is a new element in our functional group. So far we've looked at hydrocarbons, we've looked at alkanes, alkenes, alkynes, and we talked a little bit about benzene as well, and they all involve compounds of carbon and hydrogen together. So they're all hydrocarbons. But today we're going to get a bit exotic and we're going to start introducing a new element into our compounds. And the element we're using is oxygen. And you're already familiar with oxygen. And not only that, you're familiar with how oxygen bonds to carbon, because you all did something similar to this both for your junior cert and earlier this year. You've drawn dot and cross diagrams similar to this one. So you can see here, this is carbon dioxide. You know what that is, right? And carbon dioxide is a molecule where there's a bond between carbon and two oxygens. And I've drawn the dot and cross diagram here. So again, I've just drawn a simpler version now. I'm just showing the outer electrons. So I've got the 6 outer electrons in oxygen from group 6. I've got the 4 outer electrons from carbon. And I've got the 6 outer electrons from oxygen here. And you can see what happens. The carbon shares 2 pairs of electrons. The 2 dots there are the carbon electrons, the 2 X's there are the oxygen electrons, and it shares 2 pairs on either side with oxygen. And we can sometimes draw that like this if we don't want all the detail of the electrons. Okay, so that's carbon dioxide, and that's a molecule that involves carbon and oxygen. So I suppose the take-home message from this is that carbon can form bonds with oxygen. All right, we kind of know that already. So what we're looking at today is something slightly different. I want you just to have a look at this dot and cross diagram here. You can see how it's different, okay? So this time it's a little bit more complicated because it doesn't just involve carbon and oxygen, it also involves hydrogen atoms. So you can see that the carbon and the oxygen only have a single bond here. So you see the difference between that and CO2 where there was a double bond, but this is just one pair of electrons because the other oxygen electron is bonding with the hydrogen on the other side. Okay, and the other carbon electrons, the other 3 that were involved in a bonding with the other oxygen in CO2 are involved in carbon-hydrogen bonds, similar to what we've seen with methane. In fact, this is very similar to methane. It's a bit like a cross between a water molecule, isn't it? We've almost got H2O there, if you look on this side of the molecule, and methane, as in CH4. So it's kind of like if you could imagine a mix between methane and water, this is what you've got. And this is called an alcohol, okay? This is what alcohols are. I'm sure you've heard that word before. It's not news to you. Alcohols are used a lot in day-to-day, obviously in beverages and stuff like that, but in lots of other things too. And we're going to use the exact same naming system as we did before. So remember our monkeys eat peeled bananas. We're going to start with meth. This is methanol. Now here I haven't drawn the dot and cross diagram. All I've done is I've drawn little dashes there to show where there's a pair of electrons bonded like that. Okay, so that's methanol. Then here we've got ethanol. You see what I've done differently? I've just replaced this hydrogen with a CH3, so I've made the chain longer. And then here we've got propanol. Can you see that? 1, 2, 3 carbons like that. Propanol there like that. 3 carbons going across. Is that okay? Yeah? So again, we could go on. We can have methanol, ethanol, propanol. I could do butanol, pentanol, hexanol, all the way up to whatever you want. And I just didn't draw them all. But what's important is that as we go down the group, the homologous series, the chain gets longer, and as we know, when the chain gets longer, the boiling point increases. Isn't that right? So the boiling point of methanol is about 68, then ethanol is about 78, then propanol will be about 98, and it increases like this all the way along, okay? The other point is that the longer the chain, the less soluble in water each of these compounds is. Okay, they're less soluble. The more similar to water they are, the more soluble they are. The longer the chain, then the more non-aqueous they are. They're more like an oil. This is the bit that's a bit like an oil. It's called aquaphobic. And this one here is more similar to water like that. Okay, so we've got hydrophobic and hydrophilic. Hydrophilic means that it's likes the water. Hydrophobic means that it's afraid of the water like that. All right, so the longer chains are less soluble in water, the shorter chains are more soluble in water, and the boiling points increase as we go down the group because there's a longer chain, there's more electrons, there's more van der Waals forces and greater intermolecular forces between them all. But you guys just need to be aware for now of what an alcohol is and how to name the first members of the series like that. All right, hope that helps. Bye-bye.